Question reads, a sample of carbon dioxide with a mass of 0.30 grams was placed in a 250 milliliter container at 400 Kelvin. What is the pressure exerted by the gas? Okay, this is an ideal gas law problem asking us to find pressure given mass in grams, volume in milliliters, and temperature in Kelvin. And it's going to require the equation PV equals nRT.
Let's just write what we have. We have T. We do not have N, so N is equal question mark.
R is 0.0821. And T is 400. And your volume is 250 milliliters, which you want to divide by 1,000 to convert to liters.
So it's going to be 0.25 liters. Well, first of all, what are we solving for? What are we looking for? What is the pressure? You have to go from grams to moles with the periodic table. All right, so you're going to get your 0.30 grams of what? CO2 over 1 times, all right, cool. So what goes down below here? Well, definitely it's going to be grams of CO2. But how do we go from grams to moles? I'll put moles of CO2 here. If you want to go from grams to moles, you got to go
to the periodic table. Number of grams in and 1 mole out.
So basically you have to go, all right, well, here's carbon, right? But we're dealing with CO2. CO2, so that's carbon plus an oxygen plus an oxygen. What's carbon's molar mass? So 12.01 plus 16 plus 16 is 44.01. So that goes here. Look, 44.01 grams of CO2 is 2. What did I write? Right here. Again, and what goes on top? Right? How many moles? 1. Whenever you do molar mass, it's always to 1 mole. All right? You punch that out. That's your N. So N is equal to 0.00681 moles. So that's your N. So that goes right here. So 0.00681. So that is that.
All right, so let's plug everything into our PV equals nRT equation now.
And temperature is 400.
Now solve for P by dividing both sides by 0.25. And P is 0.895 ATM, which is basically 0.9 ATM.